Alrighty guys, we're going to start with the 10.3c worksheet. I'm going to go through it mainly because I'm not there to walk through it with you, so I just thought I would do this so that you can get it done and not waste your time. So 1 through 3, hold off on doing. We are going to do them. We're going to do them with 10.3d. However, I don't want to do them right now, so I'm not going to penalize you if you don't do them today. If you should be able to do them because we've already covered them, but if not, it's okay. We can go over it or do them when we come in on Monday. So this one says to use the ratio test to determine whether each series is convergent or divergent. So with the ratio test, you always need your general term, which is usually given here. Sometimes we have to write it, sometimes we don't. And then you always need the next term. And the way we abbreviate the next term is by adding 1 in the subscript. So I'm adding 1 here, but be very, very careful here, because when I do 2 and I put the n plus 1 in for n for this guy, and then I still have to do factorial after it, that's actually going to be 2n plus 2. So this is 2n plus 2 factorial. So you have to be really careful about that guy right there. So this is what the ratio test. First of all, you always have to take a limit. And we're saying as n goes to infinity of the absolute value. Ratio test is the only one with the absolute value. The bigger term, or the next term, divided by the first term. And you need the absolute value. So you have to have the limit, you have to have the absolute value, you don't have to have this step every single time, but I'm just showing it because I'm nice. Okay, so then the next thing we're going to do is fill this in. So this goes in here, and then a sub n always goes in the denominator, and then we copy dot flip. So I'm taking a shortcut here so that we don't have to show that copy dot flip step, I mean the one before copy dot flip. So here's this a sub n plus 1 and then a sub n, but I gotta flip it because I'm doing copy dot flip. Watch where your factorial goes to. You want to make sure it's on the outside of the parenthesis. Oops, I just messed that up. So this one should just be that n factorial. And then close out your absolute values. Okay, so next we're going to simplify within the absolute values. They're a type of grouping symbol, but they're also a math operation. So what we need to do here is we need to simplify this so that it'll cancel with this. So n plus 1 times n factorial. So the idea behind this right here, I'm going to use a number. So if I have 7 factorial, you guys are pretty good at knowing that 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Well, what if I wrote 7 factorial as 7 times 6 factorial? Aren't those the same thing? So I can take 7, which is from here, and then that 6 factorial, I can write it like that. The purpose of doing that with the ratio test is so that I can now n plus 1, to get to the next one, you subtract 1, so n plus 1 minus 1 is just n, and since I have n factorial down in the denominator, I'm going to be able to cancel it. So the next one is this 2n factorial, and I'm not going to change that because I have a bigger one down here, so I'm always going to change the bigger one to get to the smaller one. So this one's going to be 2n plus 2. And then if I subtract 1, it's 2n plus 1. But 2n plus 1 is not going to cancel with that, so I need to subtract another 1. And then I still have this n factorial. So I just want to go ahead and see if I can find a highlighter close by. Oh, yep, here we go. Okay. I just really want to point out what is happening here. This n plus 1 factorial is changing to n plus 1 times n factorial using this idea up here. That 2n factorial is staying the same, and then the 2n plus 2 factorial didn't just stay one term, it didn't go from one term to two terms like the yellow did. I had to go all the way down to the third term in order to get it to match that, to cancel out. So now this 2n factorial cancels and this n factorial cancels. Okay, so I'm left with the limit as n goes to infinity of, in the numerator, just n plus 1, and in the denominator I have this 2n plus 2 times 2n plus 1, which I'm going to FOIL into 4n squared plus 6n plus 2. Okay, so now that I'm completely simplified and FOILed, now I can get rid of my absolute value, and because right here, I'm just going to divide by the highest power in the numerator. So still have the limit, but I can drop my absolute value because I don't need it anymore. I'm completely simplified, and I can see that it's going to be positive. So n divided by n squared plus 1 over n squared all over 4n squared over n squared plus 6n over n squared plus 2 over n squared. And when I do that, I get the limit as n goes to infinity of 1 over n plus 1 over n squared all over 4 plus 6 over n plus 2 over n squared. And now is the point where I'm going to evaluate my limit. So this is what we were going over with in the 10.3b lesson. 1 over n is just going to go to 0 because it's going to get smaller and smaller. And so is 1 over n squared. And then 4 is a constant, and the limit of a constant is the constant. And then these are just going to get smaller. So I end up with 0 over 4, which is 0. And then I need to finish this. This is less than 1. So if the ratio is less than 1, we say by the ratio test, the series is convergent. So the way that I remember that less than 1 is convergent is because it's a ratio, and just like infinite geometric, if it's less than 1, then it has a sum, which means it's convergent. And if it's greater than 1, then it doesn't have a sum, which would mean it's divergent. Okay, so that's where it comes in, that ratio that you're setting up. Okay, let's take a look at number 5. So for number 5, we're going to move just a little bit quicker. Maybe it's a little bit trickier, so I'm going to try and use my different colored pens. We did one in the notes, but I just really want to make sure that you guys can see where this stuff is coming from. Okay, so we have a sub n. You're always going to see me write a sub n because it's just a good practice. So you're always going to see me write it. I know it's right there, and then a sub n plus 1 is going to be negative 1 to the n plus 1, 3 to the n plus 1, all over n plus 1 cubed. And it's super important that you keep your negatives in parentheses, especially in this situation, so that you don't lose things that shouldn't be lost. The limit as n goes to infinity of, I'm going to write these in different colored pens just because. So we have negative 1, and I'm doing the n plus 1 because it always comes first, times 3 to the n plus 1 all over n plus 1 cubed. And then this is getting multiplied. I think I'm doing something that I didn't want to do, but it's fine. Yeah, I'm going to switch some things out for just a minute. I'm just changing the color. Don't worry about it. It's going to be fine. Okay, you're probably writing in pencil anyways, so don't trip. Okay, 3 to the n plus 1 all over, we'll just do this one in a different color for fun, n plus 1 cubed. Alright, that's the color. So I don't know if you can see this one. It's not really that easy to see the difference. This one's in blue. Right up there. And then green and then purple. Alright, times, and then I gotta copy dot flip that. So I'm gonna do this as n cubed. By the way, no puppy killing. This isn't n cubed plus 1 cubed. We have to FOIL that out. That's going to be a little bit tedious, but I mean, we can do it. No big deal. All over negative 1 to the n. And then this is going to be 3 to the n. Alright, so there's my nice color coordinating, even though it's hard to tell the difference between the blues and the greens, whatever. I tried. Okay, so now what we're going to do is reduce these things right here. So this is negative 1 to the n plus 1, and the whole bottom is being multiplied, and there's a negative 1 to the n. Okay, now when we originally learned how to do exponents, if we had 2 to the 8th over 2 to the 5th, the rule was keep the base and subtract the exponents, so this would be 2 cubed, right? That's what it would look like. So the same thing is here. You keep the base, and then we have n plus 1 minus n. The n and the negative n canceled out, and that's just negative 1 to the first power. So the limit as n goes to infinity of negative 1 to the first power. So that gets rid of these guys right here. So I took care of this, and I just start with the first term, so it's negative 1 to the n, and see if I can reduce it. And now I have 3 to the n plus 1 and 3 to the n. So using the same idea up here, if I have 3 to the n plus 1, it's going to be minus n, and again they cancel out, but this time what's different from your notes is the 3 is going to stay in the numerator. So it's still 3 to the first power. We don't normally write when things are to the first power, but this might be helpful for us, right? And then we have the n cubed, which cannot be simplified, all over the n plus 1 cubed, which we're going to take care of in a minute. So first thing I'm going to do is take care of this absolute value. Negative 1 times 3 is negative 3, but the absolute value is going to make it positive, and since it's a constant, I'm going to put it out in front. And then I have left the n cubed all over, and then I have to fill this out. So you're more than welcome to do n plus 1 times n plus 1 times n plus 1. Go for it. That's your choice. However, I'm going to do Pascal's triangle because I know the patterns, and since the second term is 1, it makes it really easy. It's going to be n cubed plus 3n squared plus 3n plus 1. So using that row, and then remember the powers of the first one go down, and the powers of the second one will go up, but since it's 1, it's all 1. And again, I've dropped my absolute value sign because I've evaluated the absolute value. Alright, so next I'm going to take the limit as n goes to infinity. So here's a little trick that I was talking about in the notes, like real briefly. Rather than dividing, I see the highest power of n as n cubed, and rather than dividing every single term by that highest power in this step right here, which kind of looks messy, if I want a shortcut, then you could totally do this if you do it properly. I'm going to wipe these guys out. I'll put them up a little bit just so that we know where they came from. You can do 1 over n cubed and 1 over n cubed. Okay, so that is the same thing as saying divide every term by 1 over n cubed, or by n cubed, right? Because n cubed times 1 over n cubed is n cubed over n cubed. If this is confusing for you, then just divide everything by the highest power of n. Here I'm doing n cubed times 1 over n cubed, which is just going to simplify to 1. So I'm cutting out some work. And then again, n cubed divided by n cubed is 1, and that's going to be 3 over n, and that's going to be 3 over n squared, and that's going to be 1 over n cubed. Okay, so then I have 3, and now I'm going to evaluate the limit, which is going to be 1 over 1 plus 0 plus 0 plus 0. So this 3 is here, and this is coming from that limit, which equals 3 times 1 over 1, which equals 3. And then this step is important, greater than 1. You have to say it's greater than 1. It's a ratio test. So and this step is important too. You have to write it by the ratio test. Yes, you have to write by the ratio test. The series is divergent. Okay, so I'm going to keep going through these, but I really recommend you pause the video and try number 6 on your own. You can get them all from me, that's no problem, but is it really going to help you? So what's ideal is that you start doing this, and then when you get stuck, you can look at the video and see where you got lost. Maybe it was just an arithmetic error, or maybe you set it up improperly. Maybe you put this one first, even though a sub 1 always goes first. And then once you get your clue, maybe not look at the rest of the video, maybe keep trying yourself as well. So again, these always have limits. The ratio test always has a limit, and it always has an absolute value. Tie this in to that infinite geometric whenever, because they're both ratios. We compare it to r, right? And it's the absolute value of r. So just think of that when you're doing these. Alright, so this one is the limit as n goes to infinity of 1 over n plus 1 times 3 to the n plus 1. And now I see that the 3 to the n plus 1 is in the denominator instead of the numerator, so I'm already kind of watching out for that. And then here's this down here, so n times 3 to the n over 1. Alright, so then next I'm going to take my 3 to the n and 3 to the n plus 1 right there. And I'm going to do the math for that. Let's do it right here. So 3 to the n over 3 to the n plus 1 would simplify to 3 to the n minus, and because this has two terms and I'm subtracting, I have to put it in parentheses. So that would give me 3 to the n minus 1. These are still going to cancel, but I get 3 to the negative 1, which was 1 over 3 to the first power. So when I simplify that, I'm going to get that this is going to be that 3 to the n and 3 to the n plus 1 is going to give me a 3. You can do it as 1/3 like that if you'd like. And then I have this one, which is just being multiplied, and then I have this n, and then down here I have n plus 1, and here I have 1. So do you have to have all those ones? Nope, you don't, but we're just doing it to be consistent. So next, if I simplify all that and clean it up a little bit, I get n over 3 to the n plus 1. I have a constant here, it's 1/3. It's easier to pull it out, so I'm going to pull it out. I don't think you'll get it wrong if you don't pull it out, but it just makes life easier later on. And because I'm pulling it out and everything is positive, I can drop the absolute value. So then I'm going to multiply by 1 over n, because it just is easier for me. Otherwise, I would divide everything by n. And I get 1/3. Again, remember, you always have to have this step where you simplify your limit. Like you have the most simplified form of it, which is this guy right here. Alright, so that's 1/3, and then it's going to be 1 over 1 plus 0. Limit of a constant is the constant. Limit of a constant is the constant. and the limit of 1 over n is 0 because it's just going to keep getting smaller. So that's going to be 1/3 times 1, which is 1/3, which is less than 1. So therefore, by the ratio test, the series is convergent. Okay. All right, let's flip it over and take care of these last two problems. Number 7 is this sequence. We don't know what a sub n is, so we have to write it. And we don't know what a sub n plus 1 is either, so it's just a little bit more work. So we're using all these things that we have already picked up. So first of all, do you see that it's oscillating? So in sequences and series, when we want it to oscillate, we do this. So that's going to make it oscillate back and forth. And then now that we have the signs taken care of, I notice that in the numerator, I'm going up by 1 each time, which means it's arithmetic. So that means it would be 1n. My rule for arithmetic is whatever the common difference is, that goes in front of n. But when I plug in 1, so if I'm looking for 1, it would just be 1, but my initial term is not 1, it's 2. So I have to add the 1 to it so that I get 2. So my formula in the numerator is n plus 1. And then in the denominator, I'm noticing this is 5 to the first power, 5 to the second power, 5 to the third power, 5 to the fourth power, which, like, you notice I said plus 1, plus 1, plus 1, and then somebody was like, that's not 4 plus 1 is not 1. Here's what it really is. It's 5, and then the bottom is 5 to the fourth power. So we have 5 divided by 5 to the fourth power, which gives me that. And when I change that to a fraction, I get 1 over 125. So it does fit the pattern. It was just reduced. So this looks like it's 5 to the n, right? Because those are increasing. 5 to the fifth power. So there's my formula for that guy. So then to find a sub n plus 1, I just need to do this. Now this is n plus 1 plus 1. So that's going to be n plus 2. All over 5 to the n plus 2. So now that I have my term in the next term, I'm going to take the limit as n goes to infinity of the bigger one times the reciprocal because we're copied out flipping, so I get to that right there. And then we're simplifying, so I'm not going to highlight as much. That should be the tricky part. At this point right here, this problem is very similar to this guy right here, right? With all the n plus 1s and stuff like that. I think I wrote n plus 2 when I didn't mean to. So let's go back and fix that. I just copied it from right there. So this should be n plus 1. If you were wondering, you were right. It should be n plus 1. Okay, so then we are going to reduce this negative 1 to the n plus 1 with that makes negative 1 to the first power. I can't simplify the n plus 2. The 5 to the n, that's going to leave me a 5 to the first power in the denominator. Again, we already showed the math for that. And then this is all that's left because we already took care of that. Okay, so I have negative 1/5. Absolute value is going to make that positive. And because I've done the absolute value, I no longer need the limit. And so we just have n plus 2 over n plus 1. Highest power divided by the highest power. I'm taking the shortcut and doing that. So I get 1/5, the limit as n goes to infinity, n divided by n plus 2 over n. I get to there. Feels like so repetitive after a while. I'm sure it doesn't for everyone, but 1 plus 0 all over 1 plus 0, which equals 1/5 1 plus 0 is 1 over 1, which is less than 1. So therefore, by the ratio test, the series is convergent. Woo! That one was fun. Wait till you see the next one, right? This one's got all kinds of factorials and things in it. So whenever you're doing these things, it is my belief, my opinion, that whenever you have something that is a fraction, like these three, and one that isn't, always start there. Okay, we have to write the rule. So hopefully you can see the numerator isn't changing at all, so that should just be a 1. But we can see the denominator is changing, and it's changing by factorials. Does everyone see that? So the way that it's going is it is going to be, if you just go 2, 3, 4, 1, 2, 3, isn't this just n factorial? Right? Whenever you're doing factorials, I suggest you go by the last number. Okay? And then that would mean a plus a sub n plus 1 is 1 over n plus 1 factorial. And then at this point, we are good to go. We always take a limit. If you don't have that limit, you're not getting credit on this worksheet because that's poor notation and it doesn't make sense. And then this is n factorial over 1. We already learned how to rewrite our factorials. So this is still going to be n factorial, but this one I'm going to write as n plus 1 times n factorial. That 1 is irrelevant, so those cancel out. The absolute value is going to go away because I can't make it any more positive. And then I'm going to multiply this by 1 over n. In top and bottom, don't just write it in 1. It's got to be written as a fraction just like that. And so that gives me the limit as n goes to infinity of 1 over n all over 1 plus 1 over n, which equals 0 all over 1 plus 0, which equals 0 over 1, which equals 0, which is less than 1. So therefore, I know you don't have to write the word therefore, I just did. By the ratio test, the series is convergent. And that is it.